Right. Good afternoon, good people. It's 12 o'clock now. Welcome to the grade 8 class, mathematics. And I want to take this opportunity to once again introduce myself. My name is Hendrik Makaneta, and I hope that you will take the time to be part of this lesson, which will certainly go a long way to help you to improve in as far as learning and teaching are concerned, but also to reinforce generally the teaching of mathematics, the concepts that are so important for you to navigate this terrain. And of course, the main thing that I want to talk about today will be the 2D as well as the 3D objects. And I'm going to restrict myself to quite a number of examples where you'll be able to notify the difference in as far as the 2Ds and the 3Ds are concerned. And we normally call it the 2D because it is a flat shape which is found mainly on the Cartesian plane with just the X and Y axis. And of course, if it's a rectangle, for instance, you'll talk about the length and the breadth only. And that is what we mean when we talk about the 2D shape. And of course, Natalie, thank you very much indeed. And the other part, the 3D objects, as you can hear, the weight object. It's a bit different from the 2D shapes because the 3D objects will certainly, if you are looking at the rectangular prism, as it is called, you will look at the length, the breadth, as well as the height. So the height comes into the picture, excuse me, when we talk about the 3D objects. So mainly those are the differences. The 3D object, you can hold it, you can actually use it, just like the microwave, for example. That's a typical example of a 3D object, in a sense that it has got the face, the front part of the face, as well as the back face, or the back part of the microwave. It has got the top face and the bottom face as well. And it has got two faces on the sides, which completes your rectangular prism to have about 6 faces. And then we've spoken about the cube as well, and we're coming to those. But before we get there, it's very important that we calculate the perimeter and the area of the squares just in order to get a sense of what the 2D shape is all about. And we might be able to compare it, as I said, with the 3D object. But today, we will be focusing a lot on the 3D object in terms of the face, the vertices, or the vertices rather, as well as the edges of the 3D objects. That is what we are going to do. But as I said, we've spoken randomly about the properties of 2D shapes, and I'm not going to waste a lot of time. You can see there we've got a triangle together with some of the rectangles, and we also have a kite. These are the 2D shapes. You should know the 2D shapes by now. And one of the main primary thing that you need to remember is the ability to calculate the perimeter of any 2D shape, be it a square, a rectangle, a triangle, a pentagon, hexagon, or any other geometric figure. We need to be in a position to find the perimeter. But how do you define a perimeter. We have defined a perimeter as the distance around the edge of the shape. So in this case, we have got a shape which is now a square. And if we want to define the perimeter of this particular square, it is simply to walk around the edge. So if you move from the top point, top left, if you move from the top left point right across, right through the edge of the shape, right up until you arrive at the very same point where you started the journey, and we say that you have completed the race. So once you complete the race, you can talk of the perimeter, just like the ground. But the key question here is that you need to thoroughly walk along the edge and not far away from the edge of the shape. You need to walk along the edge. If it is a soccer ground that we are talking about, then you need to be walking on the lines that are marked. That particular edge, that's the one that we are referring to when we talk about the perimeter of a shape. And of course, it's very important just to reflect on this particular concept of a perimeter, which, by the way, does not go alone, but it is often defined in collaboration with the square, in fact, with the area of the particular square. So in this case, we are calculating the perimeter of a square. And who can tell me, even in the group chat is fine, what will be the perimeter of this square that we have now in our midst? I've given you all the sides. Natalie has said the area, the perimeter will be 8 centimeters. Great, Natalie. So basically, you need to add all the sides together in order to find the perimeter. And Natalie has shown us 2 ways in which we can do this. One is to multiply the side by 4. Remember that the square consists of 4 sides. Therefore, if one side is 2 centimeters, then to get the perimeter, you simply multiply the side by 4. You multiply that one side, which is 2 centimeters, and you multiply that by 4. Why do you multiply it by 4? Because there are 4 sides of the square. So perfect, Natalie, 4 times 2 or 2 times 4. You can use them interchangeably. So 2 times 4 gives you 8. If you don't want to multiply 2 by 4, then you can add them together. Remember that multiplication is the same as repeated addition. So if you repeat 2 plus 2 plus 2 4 times, that is the same as multiplying 2 by 4. So multiplication is the same as repeated addition. And that is what we mean when we talk about the perimeter of the square. And in the same note, if you were to find the area of this particular square, you must also be able to analyze the formula to calculate the area of the square. And we should know by now that the area is given by the formula A is equal to length multiplied by length, or side times side. So you can call it length or you can call it side, that is fine. And if you multiply the 2, you should be able to get the area. So another example, of course, of the perimeter and the area given again in the square. You can see that this square consists of only one side that is equal to the rest. Remember that in a square, all sides are equal. All the 4 sides of a square are equal. So even if you are given just one side, then you know that you can be able to find the rest because all 4 sides are equal. So in order to calculate the perimeter in this particular square, once again, you can follow Natalie's example of multiplying the side by 4. And you have seen the example just at the top there, that if you don't want to multiply really, you can just add all the 4 sides. So multiplication is the same as repeated addition. So if you add 6 plus 6 plus 6 plus 6, you know that 6 plus 6 is 12, 12 plus 6 is 18, and 18 plus 6 is 24. Therefore, the perimeter of this particular geometric figure is 24 centimeters. That is the square. So that is the perimeter, sorry, not the area, but the perimeter. So the perimeter of this particular square is 24 centimeters. You simply add 6 and 6 and 6. All the four sides must be added together. Alternatively, just as Natalia has shown us, you can demonstrate that P is equal to 4S. And if you substitute correctly, because it's very important to substitute correctly, you just simply multiply 4 by 6 to get 24. So 24 centimeters will be the perimeter of this particular square. Now, we have not calculated the area, and that is deliberate. The reason being, I want to give you an opportunity to calculate the area of the square in square centimeters. You are the ones who must now calculate the missing area of this square in our midst. So please calculate the area. I see that, let me see, Natalie was the last one to speak on the group chat. Let me test once again. We have got about 16 participants in this case. Natalie, once again, you find 64, but can you just explain to me, how did you find 64? Okay, you're asking me, is it 64? Right, I just want you to go back to the formula to calculate the area. It is very, very important that you utilize the formula to calculate the area correctly. So I see Cesar says 36 square centimeters. And Cesar did not show us how to get the area, but you just gave us the final answer, which, by the way, I fully agree with. That is the correct answer, Cesar. I fully agree with you. And you have just explained that you are multiplying the length by the breadth. Okay, yes, definitely. Although the length and the breadth applies mainly in the rectangle, because in a square, all sides, remember, all sides are equal. Therefore, it's just the side times the side, or the length by the length, simply because they are equal. You don't really have the length and the breadth. You just have the length because all the sides are equal. So the answer, yes, Natalie, the answer will be 36 square centimeters. And how do we get it? You multiply 6 by itself. Basically, that is what you do. So the answer, 6 multiplied by 6, gives you 36. Alternatively, you can just say 6 squared. Yes, I fully agree. Natalie there saying, alternatively, you will then have 6 squared, which will give you 36. So yes, Natalie, I'm glad that you can now see how we have managed to get the area of this square, which is given now in our midst. And of course, just to recap on the area of a square, you should know by now that in any square, you simply multiply the side by the side. So you can see in this particular case, we are given the sides as A. A represents the side, but this square consists of a base and the height. So basically, you multiply the height and the base together in order to find the area of the particular square. That's what you do. But under normal circumstances, you can just say the area A is equal to S times S or L times L. So in the example there, you can tell that if the value of A is 3 units, if the value of A is 3 units, then The area will be calculated as 3 multiplied by 3. And of course, if you multiply 3 by 3, you will definitely get 9. So 9 will be, in terms of the square units, 9 will be the area of this square. Hopefully it makes sense. And thank you once again for taking the time to participate, particularly Cesar and Natalie in the first instance. And I'm just going to give you now just an activity which all of us must participate in before we can wrap up this lesson on the 2D shape and proceed into the 3D object. Cesar, please go ahead, just calculate the area as well as the perimeter of the square where the length is 10 centimeters. And of course, the area of the rectangle together with the perimeter where the length is 65 meters and the breadth is 30 centimeters. So you can tell that we are now given the different values there in terms of the square. I can see that Amogelang has already done the first one where she managed to show that the perimeter will be 40 centimeters. I see, Amogelang, you said 10 multiplied by 4, and I see you got 40. Right. That is one way of calculating the perimeter. And another way is to just add all the sides of a square, 10 plus 10 plus 10 plus 10. So that will give you 40 centimeters. And Cesar, I see you moved to say 40 centimeters and 100 square centimeters. Great, Cesar. I can tell that what you did is correct because you calculated the perimeter and the area. Remember that the area is given by the formula 10 times 10. That is the length multiplied by the length. And 10 times 10, as you know, will give us 100. So it will be 100 square centimeters. And Tlantla as well, I see you weighed in on the first one, which is A, by multiplying 10 by 4. So Tlantla says 10 times 4 is 40. Thank you very much indeed, Tlantla. That's the correct answer as well there. So 40 will be the perimeter in that particular square, in the first square. So now that we are done, we've exhausted the first one. We need to now zoom directly into B without any waste of time. I see that some learners are still busy trying to work out the first one. Please do so. Cesar has already found the perimeter as well as the area of the rectangle. And I see you say that the perimeter is 190. Okay, even Natalie says so. You agree with Cesar. The same goes for Tlantla, who says 65 plus 30 gives you 95, and then 95 times 2 is 190. Great. So you first added the two sides, and then you multiplied them by 2. Great. Alternatively, apart from what Tlantla said, Natalie also says the perimeter is 190, and the area, I see that Natalie has calculated the area as well, together with Cesar. Great. What we simply need to do in this case is just to demonstrate that when you calculate the perimeter of a rectangle, once again, this is the distance around the edge of the shape. So basically, the distance around the edge, you simply add all the 4 sides. So it's very important that when you have a question of this nature, just make sure that you draw the actual figure there. The rectangle, you must draw it with the length of 65 centimeters. So if you draw the rectangle, you are likely not to go wrong, because then you will be able to see that one of the sides will be 65 centimeters, followed by another side which is 30 centimeters. But since the rectangle has got 4 sides and not 2 sides, then you'll appreciate the fact that the opposite side of 65 centimeters will be also be 65 centimeters. And the other opposite side of the 30 centimeters will also be 30 centimeters. So basically you'll have 4 different sides, and it's up to you how you add them together. You don't have to, you can use a formula if you want. Remember, the formula for the perimeter is given by the formula P is equal to 2 open bracket L plus B. So basically you add 35 and then as well as 60 to get 95, and then if you multiply 95 by 2, you get 190. So 190 centimeters will be your actual perimeter. And then the last one, of course, was the area. Remember that in any case, the area to calculate for the rectangle, the area of the rectangle is calculated as follows. A will be equal to length times breadth, and the length is 65, and the breadth is 30. So you simply multiply the 2. I see that most of you got 1,950 square centimeters. So I hope that we have done justice to the 2D shapes. We might as well proceed to the 3D objects. I think that we have done the necessary justice to this topic, and I'm not going to waste any time but to zoom directly now into the 3D objects. So we are talking once again about the 2D shapes as well as the 3D objects. Great. Natalie was just asking, is it a must to write L times B when we calculate the area? Yes, Natalie, it's very important to demonstrate how did you arrive at the final answer. So it's very important to just write the formula, and you know, depending on the marks that are allocated, but I would advise you to write the formula all the time because it will basically serve as the guideline just to guide you as and when you substitute, so that you can be able to substitute correctly. So the formula serves as a guideline. Thank you very much indeed. Natalie, thank you for that question. Right, I'm now going to talk about the 3D objects, and the first one that you can see on the top left, we have the cuboid, also known as the rectangular prism. So this is a rectangular prism. So it's a prism that is made up of rectangles, if you can call that, because if you take the 4 rectangles and then you add them together in a paper there or the net, and then of course you can have the last 2 rectangles, small as they may be, or the squares, it's right up to you. Then you can complete a cuboid. We know how to, we all know, I believe, how to find a net, or maybe you know how to do the net for the cube. That's okay. So to do the rectangular prism as well, you also need a net, and the same goes for a cube. The reason being, these are objects which you should be able to carry. If you take out a page or an A4 paper, you can be able to fold it in such a way that you can construct a cone. Just like the ice cream, the cone for ice cream, you can use the paper to find or make a cone. That's okay. So a cone is also a 3D object. And the last one is the sphere. So the sphere, you can see it looks more or less like a soccer ball. So that's what we mean when we talk about the sphere. So the sphere is very, very important as well. And we are now going to rely on the 3D object to define some of the important concepts which will follow as we proceed, as we move forward. If you look at some of these 3D objects here, they have got different properties. So we call this the property sheet. There are different properties in relation to the face, the edge, and the vertices. If you check the top one there, we are looking at the prism, something called the hexagonal prism. And that is what I'm trying to look at today. The hexagonal prism at the top right, this prism here. This is what we call the hexagonal prism. You can see the two opposite faces are hexagons, which are now joined together, you know, every corner to the corresponding corner to complete this structure or this object, which is known as a hexagonal prism. So we now have a prism where the base and the top are equal and they constitute a hexagon. Just next to that, you can see also we have the pentagon. The pentagon is just a five-sided figure, as you know, and that too will have its own faces and the edges. So the first one, which is a hexagonal prism, consists of about 8 faces. You can see that the middle faces will be 6, and the top face and the bottom face, those are 2. So if you add them together, they complete 8 faces. And then we can also look at the triangular prism, which is there just below the hexagonal prism. We have the triangular prism. So you can tell that it is made up of 2 triangles, which are faces, which are facing each other, together with the rectangles, about 3 of those. So you need 3 rectangles in order to complete this particular geometric figure, which is known as the triangular prism. So a triangular prism as well is demonstrated. And then we also have the different others, like the, yes, that was the triangular prism, but you also have the rectangular prism, which is, you also have a cone. You have a lot of prisms there. You also have the cube. I've already spoken about the pentagonal prism, and now I'm going to focus directly on the first example, being the triangular prism. And I hope that you are observing the different 3D objects so that you can be able to answer the questions that will follow. And these questions will be limited to the face, or the faces rather, of our 3D shapes or 3D objects rather, together with the edges and the vertices. So up to now, I'm sure that you know, you should be able to understand what we mean when we talk about the face of a particular 3D object. Just like the example that I gave in the morning or in fact this afternoon rather, when I started the lesson, I spoke about the microwave. When I started speaking about this 3D object, I said that the microwave is a typical example of a 3D object, and it consists of about 6 faces. So definitely you have 6 faces of any particular cube or any particular rectangular prism. Right, let us now start. Without wasting time, I'm just gonna show you, just to summarize the different 3D objects which are there on the board now. We have the square-based pyramid, but we also have the triangular prism. So you must be able to differentiate between some of these 3D objects. We also have the rectangular prism. So you can see we have a triangular prism, we have a rectangular prism, we have the square-based pyramid, we have a cube, we also have a sphere, as well as a cylinder there and the cone. Now, I want you to answer the following questions. Given the shapes on the table above, I want us to find the number of vertices in each case, followed by the number of faces and the number of edges. And I'm going to start with a triangular prism. Before we go to a rectangular prism, let's start with a triangular prism. How many vertices are there? I see Natalie says 6 vertices, and I agree with you. Remember, when we look at the vertices, we look at the angles. Remember that the angles actually inform the vertices or the number of vertices that we have. So a rectangular prism, as you have seen, consists of 2 faces of triangles. So if it has got 2 triangles or 2 faces of triangles, then it means it will have 6 vertices, or vertices rather, because every triangle has got 3 angles. So every triangle consists of 3 angles. So you'll have 3 angles, and then to demonstrate or to find a way to calculate, you simply need to show that 3 angles plus 3 angles gives you 6. So I see in Tlantla as well, you have found 6 angles. And of course, Amoelang says 9. It can't be 9, Amoelang. It's just 2 triangles, therefore 3 angles each. 3 plus 3 is 6. So you'll have 6 vertices in a rectangular prism. Now let's talk about the number of faces. Or you are talking about the edges. Yes, Amoelang says 9 edges, I agree. Natalie also, 9 edges, yes. If you're talking about the edges, I agree. And then Cesar says 5 faces. Natalie also says 5 faces, followed by Musa and Tlantla, 5 faces. Yes, it will be 5. The first 2 faces, those are triangular faces, followed by the rectangular faces will be 3. So 3 plus 2 is 5. So you'll have 5 faces in this case. Right. We are done with the triangular prism. Let's go now to the rectangular prism. Let us zoom directly into the rectangular prism, and let us find a way to calculate how many vertices are there in a rectangular prism and how many faces are there in a rectangular prism. And of course, let's also look at the number of edges for a rectangular prism. So I see Natalie says 8 vertices, supported by Lesedi, supported by everyone else. You are saying there are 8 vertices. I fully agree with all of you. There will be 8. There isn't be. Remember, these are rectangular prisms. So there will be 2 rectangles that are joined together to form to complete a rectangular prism. And then each rectangle has got 4 angles. And the second rectangle also has 4 angles. If you add those together, they will give you 8 angles. So it is 8 vertices that are found. And the faces, remember, the faces will be 6, as Lesedi says. There will be 6 faces. What about the edges or the number of edges? I see Nhlanhla edges is 12, and Natalie also found 12. Lesedi also found 12. So 12 edges in the rectangular prism. Let's go now to a cube, which is now the last one before I give you an opportunity to write this class activity. Let's go now to a cube. A cube also will have a number of vertices. How many? I see Onke together with Natalie and Nhlanhla say there will be 8 vertices. I fully agree. Remember, a cube is not different from those. If you join those 2 squares, in fact, in such a way that all you have is squares all around the 5 faces, then you'll see that the vertices will be 8 as well. Remember, a square has got 4 angles as well. So the second square, which happens to be the opposite face, will also have 4 angles. And 4 plus 4 is 8. And the faces, we have spoken at length about the face of a cube. So there will definitely be 6 faces. And then the edges will be 12, just like the rectangular prism. You will have 12 edges. So basically, that is what you do in relation to the triangular prism, the rectangular prism, and the cube. Right now, I want you to take your pen and a paper just to use the same table that we have here in our midst and tell me now the number of vertices for a pentagonal prism followed by a hexagonal prism, the square-based pyramid, the pentagonal pyramid, and the hexagonal pyramid. Surely there is a distance or there is a difference between the pentagonal pyramid as well as the pentagonal prism. So the pyramid and the prism are not the same. So just note that, and the same goes for the hexagonal prism as well. It will be different from the hexagonal pyramid. Remember, with the pyramid, you always have the top part of the particular pyramid forming only one vertex. So you do not have more than one vertex when it comes to pyramids. Be it a square-based pyramid or not. No, you can just send them directly, Natalie. It's fine. You can send the answers directly. I have no problem. You can send the answers directly. So if just to take you back, I'm sure you will appreciate just to, when I show you the different 3D objects, just the second row, the second last row, the first picture there of the second last row demonstrates what a pentagonal prism is. You can see there, there are 2 faces facing each other, which are those of the pentagons, but there are also 5 other faces on the side, which completes 5 plus 2 to be 7. So you can see there are 7 faces, but in this case, the vertices will be 10. Why 10? Because the pentagon on its own has got 5 angles. So there are 5 angles in a pentagon. So if you have got 2 pentagons that are joined together to form a prism, then it means you will have 10 vertices. All right, so you'll have 10 vertices, and then the edges will be 15. Remember, the first top there will have about 5 edges. The bottom top, the bottom one, or the bottom face rather, will also have 5 edges, and then the middle one there will also have 5 edges. So if you add them together, it must give you 15. So there will be 15 edges in for the pentagonal prism. And then the hexagonal prism, you do the same. You can see we have got the top one there. The top one, the top right, that's a hexagonal prism. And it consists of 12 vertices. Why is it 12? That's because one hexagon consists of 6 angles, and the second one consists of 6 angles as well. Now it gives you 12 all in all. And then the face, as you can see, you'll have the first 2 faces. The first hexagon there at the top, that's a face on its own, and the bottom hexagon is also a face. In the middle, you'll have about 6 different faces, because remember that this hexagon has got 6 corners. Therefore, the middle faces there will be 6. So if you add them to the 2, the top and the bottom one, you get 8 faces in total in a hexagon. I hope that you can see that. And the edge, you do the same. Just as we did the edge of the pentagonal prism, you do the same with the hexagonal prism. Remember, the top one consists of 6, and then the middle one will be 6, and then the bottom one will be 6. So 6 times 3 is 18. So the edges will be 18. I'm glad brother says 8 faces and then 18 edges. And that is the hexagonal prism. Can we do the square-based pyramid? Just to close, as we close our lesson, can we finalize now the square-based pyramid? That is the last one before I give you the homework. The square-based pyramid, and it should never ever be difficult to find the square-based pyramid. I see Natalie says 5. Which ones are you talking about, Natalie? Are you referring to 5 faces or vertices? All right. I see Cesar says 5 faces. I'm glad you can see the 5 faces. I hope you are not using Google to find these answers, but you're actually drawing the square-based pyramid, and I agree with you. There will be 5 vertices in a square-based pyramid, and there will be 5 faces as well. Remember, there will be 4 faces around the shape, and the bottom face, which is a square, is the 5th one. So there are 5 faces all in all. Now, in order to calculate the edge or the edges, remember that our square there consists of 4 corners there. And of course, when you move around the shape, you'll also have about 4 vertices there, so 4 edges. In other words, 4 plus 4 gives you 8. So you'll have 8 edges in relation to the square-based pyramid. Now, without wasting time, I want you to concentrate on the remaining aspects of the questions. And thereafter, please make sure that you calculate how many faces are there in a pentahedron as well as a heptahedron. And the last one is the octahedron. So you finalize the hexagonal prism, in fact, the pentagonal pyramid and the hexagonal pyramid. So remember, the pyramid, you will only have the one vertex at the top of the pyramid, And then, of course, you can use the pentahedron just to find out how many faces are there. As a guideline, please do not hesitate to use some of these concepts or some of these 3D objects. Once again, this lesson is brought to you by the STEM Digital School in partnership with Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.